So today we're going to continue to talk about analytic geometry, equation of a line, and some top properties among that. But the same set of skills are going to keep coming up to determine the equation and be able to sketch lines. So today we're going to talk about what does it mean to have a parallel line versus a perpendicular line. So we've kind of already figured out that parallel lines have the same slope. All right, so that m value has to be the same. What we're going to look at today is that perpendicular lines meet at right angles. And I think we feel really good about that in terms of, as a picture-wise, we can see that they meet at 90 degrees. No problem. One of the things that we're going to look at is, what does it mean to have negative slopes or negative reciprocals? And we've talked about that reciprocals when we were dividing by fractions. So if I had a slope that was 2 over 3, that negative reciprocal would make it m equals negative 3 over 2. So we do the reciprocal of the fraction and we change the sign, and that's where the negative part comes in. Okay, so kind of keep this as a little bit of a guide as we go through today. I'm learning that when you multiply the slopes of the perpendicular lines, the result is always -1. And not too much about that, but we'll go through. So classify each pairs as line, parallel, perpendicular, or neither. So to do that, there's a couple ways of showing that. We can show it algebraically. All right, so we can compare the slopes from the equations. And we should be we'll look at it graphical as well. So this is where the analytic geometry comes into play. So if I'm looking at line 1, so let's call this line 1 and line 2. All right, line 1, we know that m is equal to 2 over 5. Okay, because we know that from that. So line 2, all right, well, I don't know the slope. So we can change to y equals mx plus b, because we're going to graph them anyways. So let's change it to y equals mx b and see what happens. So I have 2x minus 5y plus 10 equals 0. Well, we're going to use our inverse operations to move things around. Well, I'm going to subtract 2x, subtract 10, subtract 2x minus 10. All right, so now I'm left with negative 5y equals negative 2x minus 10. And then I can divide both sides by negative 5. All right, so now I have my second equation is equal to 2 over 5x plus 2. So if I'm looking at these, the m of this one is 2 over 5. Well, line 1 and line 2 are parallel since they have the same slope of 2 over 5. Okay, so we can still sketch these guys. All right, so this one had a b value of -1. So -1 right there, and I'm going to go up 2 over 5, up 2 over 5, backwards. All right, and the work that I saw from some of you guys in terms of graphing these lines was awesome, so I'm not worried about that at all. All right, just draw your line with a ruler. Okay. And we'll label that as y equals 2 over 5 x minus 1. And this next one is +2, and it has the same slope. Okay, same slope, parallel lines. Okay, so let's draw a line in. Let's make this one blue just for the sake of it. All right. And this line is y equals 2 over 5x plus 2, or 2x minus 5y plus 10 equals 0. Okay. Parallel. All right. Simple as that. So we can see that they never touch moving forward. And a lot of these skills that we're showing right now are going to be skills that you guys will use in grade 10 when you get into analytic geometry in terms of different shapes like triangles and parallelograms and stuff like that. So keep these things in mind. All right. So let's look at the second example here. I have line 1. All right. I have, and slope is 3 over 1, or 3 is fine. B doesn't matter too much, but we're going to sketch it anyways. So we got B is -4, and then I'm going to go up 3, run a 1, up 3, run a 1, up 3, run a 1, and so on, and I can reverse the pattern going backwards. All right, I'll graph my line here to start. Let's see here, let's pick blue again. All right, we'll just straighten that out just a little bit. All right. All right, so there's my first equation. Okay, y equals 3x minus 4. So we're going to take a look at this guy, and we could sketch this in terms of x-intercept, y-intercept stuff. I'm not a big fan on that, just because it's sometimes it doesn't work out nicely, especially with actual y-intercept. But if I change this form, all right, subtract x, add 15, subtract x, add 15 to both sides. So I've got 3y equals -x plus 15. All right, and we'll divide by 3, divided by 3, divided by 3. So I'm left with y equals, and we're going to, there's my -1/3, and 15 divided by 3 is 5. Okay, so what I know from that is my slope is -1/3, and my b value is 5. So I can go here at 5, and I go down 1, run a 3, down 1, run a 3, down 1, run a 3. All right, and I can graph my line. All right, little arrows. Put little arrows on there. And you look at that, it looks like 90 degrees. It looks like we have a right angle. Okay. And I'm going to tell you it is. Okay, because these two slopes here, let's do purple, are negative reciprocals. All right, because 3 over 1, if I do the inverse, becomes 1 over 3. This becomes positive to negative. Therefore, they're perpendicular. All right. So line 1 and line 2 are perpendicular, since the slopes our negative reciprocals to each other. Done. All right. And I'm going to go back and just tidy this one up. So this equation was y equals negative 1/3 x plus 5. All right. That's the goal. All right. All right, let's look at one more. Why don't you guys try to sketch these lines? All right, and I'll come back and I want you to tell me if they're parallel, perpendicular, or neither. Tell me what you think, and I'll show you my answers here in a few minutes. All right, we're back. So what I did was first line, I figured out that my slope was 1/2 and my y-intercept is -3. All right, that was pretty straightforward. And my second graph, I said, well, let's change it so it's equal to y equals mx plus b. So I subtracted 2x from both sides, and I added 1 to both sides to move everything away from y. All right, and then I had to divide by -1 to get rid of that negative sign in front of the y, and that's why I end up there. So before I show you the graphs, you might think to yourself, those are perpendicular lines. Well, if I look at this, for them to be perpendicular lines, they have to be negative reciprocals. Well, these are reciprocals, but they're not negative reciprocals. So when I show you the graph here, all right, and move forward here, all right, those are definitely not negative reciprocals. Or perpendicular, because it has to come with a negative slope on it. So these guys are definitely, they're not, basically they're neither parallel nor perpendicular, since the slopes are neither the same nor negative reciprocal. To each other. Okay. So I'm just going to get rid of those. Okay. So that's our deciding line. All right. So I'm going to put the equation on for the other one. So this one is 2x minus y minus 1 equals 0. So there's my answer. Neither parallel nor perpendicular, since the slopes are neither the same nor negative reciprocals to each other. All right. So that's the basic idea. These concepts about changing it to y equals mx b is from previous learning, but that's why we learned it, so that we can build on to answer bigger questions. Okay. Using properties of an old line to create a new line. So this is kind of where the end goal is for our learning with analytic geometry. Okay. So what we're going to do is we're going to take some properties of an old line to make a new line. So we're taking some slope or y-intercept or stuff, a point from something else, and making a new one. So this is draw a line segment that is parallel to the line segment with endpoints 1, 2, and a line segment that is perpendicular to it. All right, so let's look at parallel. Well, we know that parallel means same slope. Well, if we want something with the same slope, we better find the old slope first. All right. And when we were finding the slope, some people were mixing up where to put the x's and y's, and maybe it came from the points or the equation. And sometimes it helps if you don't like how these points are written, all right, that's fine. But sometimes it helps to put like x1, y1, x2, y2, so it catches you for when you sub it in. Okay, so y2 is -1 minus 2, and then 5 minus 1. Okay. If you don't like those points, set it up as a table. Here's my x and y, 1, 2, and 5, -1. I know that here I'm going to have to subtract 3, and here I'm going to have to add 4. Well, guess what? The top is -3 and the bottom is 4. That's okay. All right, so there's my old slope. So we want a line that's parallel to that line. All right, so parallel. All right, well, it's got to have the same slope. So any line that is parallel to it just has the same slope. So let's, just for argument's sake, let's plot 1, 2, and 5, -1. Okay, there's my very old line. Okay. All right, and I'm going to extend that line. All right, as long as it's not 3, it doesn't matter. Okay. So my parallel line, or my new line, we just got to make sure that, and it's not even 3, but as long as my slope is -3/4, we could choose any b value at all right now. So I'm going to choose y equals -3, 4x, I don't know, plus 7. But basically, I can choose any y-intercept. Okay. Draw a line that's parallel to that. So I'm going to draw that one. I'm going to start at 7, down 3, run a 4. Down 3, run a 4. All right, same. All right, done. Draw your line. All right, there's my parallel line. Okay, well, perpendicular. All right, well, the only thing crazy about this, I just need the slope. I just have to change it to the negative reciprocal. All right, so my new slope here now is now 4/3, negative reciprocal of my old slope. Okay, now I can draw that in. Doesn't matter. Okay, here's the line I'm going to draw. Positive 4/3 x, I don't know, -5. That's what I'm going to draw. But I can just choose any y value. You choose. All right. All right. Up 4, run a 3. Up 4, run a 3. All right. Down 4, run a 3. All right. So now I'm going to draw my line. All right. The sound effects are optional. All right. So there's my perpendicular line. That's it. So parallel, same slope, perpendicular, negative reciprocal. That's it. All right. So some really short questions here, and this is going to build on to new learning as we move forward. If a line is perpendicular to this line, what would be its slope? Well, we got to find the slope. All right. So in this case here, maybe I'm going to change to y equals mx plus b, because we know what the slope is. So I have 5x minus 3y minus 12 equals 0. Subtract 5x, add 12. Subtract 5x, add 12. So negative 3y equals negative 5x plus 12. I can divide negative 3 by everything. So I've got y equals 5 over 3x minus 4. So we know from this is that my old slope, m equals 5 over 3. Well, our new slope has to be perpendicular. Okay, so it's got to be a negative reciprocal. Okay, so negative 3 over 5. Done. Okay. Change forms. All right, if a line is parallel to that, what would be its slope? Same idea. Change to y equals mx plus b. All right, 2x minus 9y plus 18 equals 0. Get y by itself. So negative 9y equals negative 2x minus 18 divided by negative 9. All right, and since it's parallel, it has to have the same slope. All right, old slope is 2 over 9. Well, my new slope has to be the same. All right, so I can look at that. All right, well, this one's pretty easy. If a line is perpendicular to this, what would be its slope? Well, right from here, we know that the old slope is equal to negative 5. And I'm going to put this over one part because it just allows us to do the reciprocal real easy. So now our new slope has to be 1 over 5 because it has to be a negative reciprocal. All right, so I'll just kind of end this off in the sentence. The slope must be 1 over 5 so that it is perpendicular to the line y equals negative 5x plus 7. Okay, just kind of tidy that off. Okay, so just to keep those minds moving forward. All right, I'm going to skip number 6, and if you want to do it, let me know. But here's the challenge. What is the slope of a line that is perpendicular to a line that has an x-intercept of 4 and a y-intercept of -5? So here's the question. When you have something that is, sometimes this could be done visually, all right? So I can look at this as a graph, all right? Well, if I'm looking at this, an x-intercept of 4, it would be at 4. That's one point. So that point would represent 4, 0. And my point at y-intercept of -5 would be down here at -5. And if I drew a line through that, okay, all right, okay, my old slope of that line is equal to rise over run. So those are the things that we've learned in the past. So I've got a rise of, let's do it this way, I've got a run of 4 and a rise of 5. So that's 5 over 4. Therefore, my new slope which has to be perpendicular has to be -4 over 5. All right, so graphically, that's what it could be done like. But some people will say, well, that's not the only way, Mr. Brzee. There's got to be a different way. Sure there is. All right, what do we know? All right, well, an x-intercept of 4, that point is 4, 0. My y-intercept of -5, that point is 0, -5. Well, guess what? I can use my slope formula, y2 minus y1, x2 minus x1. So this is going to be my x1, y1, x2, y2. Right, so I can sub that in. y2 is -5 minus 0 over 0 minus 4. Well, that becomes -5 over -4. Well, if I get rid of the negatives, there's my old slope. So my old slope is m equals 5 over 4. All right, well, my new slope, again, has to be -4 over 5. So it can be done graphically, or I can use algebra. But in the end, it doesn't matter. All right, show your thinking. This is justifying your thinking moving forward. Okay, so we have tools. We have a graph. We have the slope formula to find a slope of something. We can use that. All right, good luck. Talk to you soon.